VSEPR, what we call the valence share electron pair repulsion theory. This will explain to us why do we say that ammonia is trigonal pyramidal while boron fluoride is trigonal planar. We need to understand the interaction between the lone pairs and the bond pairs in the last shell of the central atom in a molecule. Those electrons that were contributed is what we call contributed by different atoms. That's what makes up the bond pair. The cross here is to represent the one from hydrogen, while the dot represents the one from carbon. You can use cross for carbon and dot for hydrogen. So this is what we call the cross and dot diagram, just to know the contributions. So they are all paired. One came here, so contributed pairs are what we call the bond pairs in a covalent molecule. So the steric number here is 4. But what makes it up? 4 bond pairs and what? 0 lone pairs. Then when you come here also, we have how many bond pairs? 1, 2, 3. We have 3 bond pairs with 1 lone pair. This lone pair is the one that is not contributed. It belongs solely to the nitrogen. So this nitrogen automatically has this pair here, and it's called lone pair. It's not participating. It wasn't contributed by 2 atoms. It's only belonging to nitrogen and is a pair. But this one here is a bond pair because 1 electron here came from nitrogen, the other came from hydrogen, and they bonded together. So this one has 3 bond pairs plus 1 lone pair, which gives us 4 as the steric number. So methane and ammonia have the same steric number, but the constituent is not the same. Methane has 4 bond pairs and 0 lone pair, while ammonia has 3 bond pairs and 1 lone pair, which will affect the shape. Then this structure here is actually water molecule, which has how many lone pairs? It has 2 lone pairs, 1, 2, plus 2 bond pairs, which is 4. Okay, for you to understand this theory, we need to understand the interactions, the different possible interactions occurring in the last shell of the central atom. So here we have distances. This is distance A. We take it as A. And we have repulsion B and repulsion C. We also have repulsion D. Just watch this drawing. You have to agree with me that A is between lone pair because this is a lone pair, this is a lone pair, and we call it lone pair repulsion. Then B is lone pair bond pair. It appears between the distance between lone pair and bond pair, that's B. Then C is bond pair repulsion. Then D and B is the same because D and B remains lone pair bond pair. Lone pair bond pair, lone pair bond pair. So we have these 3 possible interactions. So it is already an established fact that lone pair repulsion is the highest, followed by lone pair bond pair. Then the repulsion between 2 bond pairs is small. That means anytime you have a lone pair in a molecule, it will affect the distribution of the bond pairs because of the valence share electron pair repulsion effect we are studying now. So in this theory, it is observed that lone pair repel each other more, followed by lone pair bond pair, while the attraction is highest among bond pair, which means repulsion is least here. This explains why the shape of ammonia is trigonal pyramidal instead of trigonal planar, and this also explains why the shape of water molecule is angular or bent instead of linear that is expected theoretically from the shape. So I will first of all explain the shape of water, which is what I have here. Water molecule is not linear as theoretically expected. The reason is because of what I have here. So drawing the Lewis structure of water, which is what we have here, but this is not the dot and line. If you want to draw the Lewis structure, you use small dots for lone pair, then use lines for bond pairs. So this structure and this structure is the same. This is oxygen. So this 4 dots shows 2 lone pairs, while this shows 2 bond pairs. So in this case, the repulsion, the lone pairs are pulling, they are pushing each other. Therefore, because they repel each other more, they will tend to bring this bond pair closer to form an angle instead of allowing them to be straight. This is not the geometry of water molecule because of the lone pair repulsion. So if they ask you why is water angular in shape instead, that's angular V shape or bent in shape instead of linear, you say because of the strong lone pair repulsion and also the lone pair bond pair repulsion. Assuming there is no lone pair and bond pair, like we only have only bond pairs, water will be automatically linear. Like in carbon 4 oxide, if the steric number is just 1, 2 without any lone pair, it's going to be linear. But unfortunately, there is 2 lone pairs, so the repulsion between them is high, pushing the 2 hydrogen atoms close to form a V shape. So let's now differentiate between the so-called pyramidal, trigonal pyramidal and trigonal planar using the VSEPR theory. So in this case, we have boron fluoride and ammonia. Normal ammonia will have 1 pair. Then that's NH3. Then have boron fluoride or boron chloride, which will give you Cl, Cl, and Cl. So this one is trigonal planar. While this one is trigonal pyramidal. Now watch this. The steric number here is 4 and here is 3. But the difference is that 3 bond pairs are all present in each of the molecule, but there is a lone pair present in ammonia but is absent in boron chloride. Remember, boron chloride is a perfect Lewis acid because it can still accept a pair from this one that have it. So if you draw the structure, you discover that boron is still deficient of 2 electrons for it to be octet stable. Therefore, it can easily accept a pair from ammonia. So when ammonia molecule reacts with boron chloride, it forms an adduct. That is for Lewis acid-base reactions. This is Lewis base, while this is Lewis acid, because it can still accept a pair of electron from each shell. Remember, chlorine will donate 1 here. Boron has 3 in the outermost shell first, and the 3 now plus one electron again donated by each of the chlorine will give you 6, which makes it still require 2 to be stable. But the 2 is not here, so it's assumed that this is lone pair 0. 0 lone pair is here and 3 bond pairs are here, but it can still accept. So to explain why this is this, if you follow me and trace this, just watch. So for you to draw the shape of this, putting the atoms at the edges, this is what we got. This is like a perfect pyramid. That's why I say trigonal pyramidal. But here, if you place each atom where they're supposed to be, this is atom in the middle, boron, then the chlorine, the chlorine, the chlorine. This is not, it's just trigonal planar, a plane. It doesn't form a pyramid. Then, this lone pair, why won't it allow this hydrogen to be straight? So remember, this is a wrong way of representing the molecule, like if you draw it straight, because lone pair bond pair repulsion is highest. The lone pair is repelling the bond pair, pushing them to come closer, reducing the bond angle to 107, which is the bond angle here should be 120. But here it has pushed the lone pair bond pair repulsion has lessened the angle from 120 to 107. So the molecule of ammonia is trigonal pyramidal instead of trigonal planar because of the presence of the lone pair there, causing lone pair bond pair repulsion, pushing the 2 atoms together. So thank you for watching. If this video has helped you in any way, please subscribe and share. I cannot do without you. Much love from me to you.
Have you heard about the majestic table? It was designed and recommended by Her Majesty himself. Here it is. The amazing thing about the majestic periodic table is that it provides a clear and colorful classification of elements, from P block metals to metalloids to liquid metals. It also shows the boiling and melting points of all the elements. It also has the unique feeling of electrons in the shells of each element.